Welcome to Study Loop.
Thank you for joining me again. We're still in chapter 13, now on to problem 40. So we're looking at what is the mass percentage of iodine in solution containing 0.035 moles of iodine in 125 grams of CCl4, which is carbon tetrachloride. B, we're looking at something very similar. Seawater contains, we've got grams per kilogram of water, and what is the concentrations in ppm? So let's start at the top. We'll worry about B as well. It's not a part 1, part 2 problem. So let's look at what our mass percent is. So let's try to do this from memory. See if you can write it down. What is your mass percentage formula? Mass percent is mass of your solute over mass of solution. And solution's made up of two parts. It is both solute and solvent added together. And we times this by 100 to get rid of the percent sign. All right, so let's see what we have. We were given our mass percentage of iodide, which is very small. And was it in mass? Mass is in units of grams. So what were we given to start with iodide? Was 0.035 moles of iodide 2. And the reason there's a 2 there is because iodine is one of those diatomics, one of our 7 scaredy cats on our periodic table that requires that they're always in pairs. So looking at our periodic table, we can find a way to convert this to grams, which is what we need. We're going to need grams of both our solute and our solvent. Even if we're not sure which one this is, we know we have to go into grams. And we know if we use the periodic table, it's always set up to 1 mole of iodide. So let's check out our periodic table, and we find that iodide is 126.9 grams per mole. And just remember, we have 2 of these, so we absolutely have to count it twice. So that's 253.8 grams. In our calculator, we just times that by our 0.035 moles. And we find out if we were to weigh that iodine on a scale, we would have 8.88 grams of iodide. Watch out for, we're going to have to watch out later when we finish up our problem for significant figures, but we're not going to take that into account just yet. All right, so let's look at the mass percent. This is, we found, our solute is always the lower number over solution. So we know that we dump this 8.88 grams of iodide 2 into 125 grams of carbon tetrachloride. Which one's larger? Absolutely by far the carbon tetrachloride. So we know that this is our solute. So let's start setting that up. We have our mass percent. It's equal to our mass of solute, which we have solved already, which is 8.88 grams of iodide. Perfect. Now our mass of solution. Our solution is both of these added together. So it is our iodide plus our carbon tetrachloride. So we're going to do 8.88 grams plus what we dumped our iodine into, which is the carbon tetrachloride, 125 grams. Remember, we need to times it by 100. And this unit never came in there. And that'll solve. So let's put it into our calculator, 8.88, and divide it by our solution, which is 8.88 plus 125. And altogether, we end up with an amount that needs to be times by 100. So if you ended up with 6.63%, then you're absolutely correct. That is the percent mass that we have in part A. And I'll give you just a moment here if you'd like to write anything down. We're going to switch over to part B of our problem. All right. Opening up a new page, we're going to work on that. So we have seawater that contains 0.0079 grams of this particular cation, which is strontium 2+. And that's in every kilogram of water per 1 kilogram. What is the concentration of strontium in ppms? Can anyone tell me what ppms are? Parts per million. So, if we want to convert into ppms, parts per million, we're just going to use a conversion factor. We're going to have, and all parts per million are, is mass of solute over mass of solution. And they gave us this. This is our mass of our solute over the mass of our seawater solution. Seawater solution. All right. So all we have to do is change it from grams to kilograms into parts per million. And that is something we looked at doing around chapter 2. And all we have to do is change it to parts per million. So we just times it by 10 to the 6th power. So what that looks like here is we have our 0.0079 grams. Just kidding, that's a 0. And that's over 1 kilogram. And we're going to switch that kilograms into grams. All right, now we've got our mass of solute over our mass of solution, and masses in grams. We like it when they're all in the same units. It makes it easier for us. And that'll help us switch into, here we are, times 10 to the 6th. Switch us into parts per million. And what we find is, multiply this all out in our calculator, 0.0079 divided by 1,000 times 1 times 10 to the 6th power. And now we are 7.9 parts per million of strontium 2+, a cation. So a trick you can use whenever you're doing this on a test is look at the beginning here and look at the end here for parts per million. And you'll notice they're very similar. They'll always be the same amount because we're only going to be doing factors of 10, groups of 10. So if you find a multiple choice question that's an 8.1 or a 6.4, any number that's changed are 7 and 9 are absolutely wrong. Good luck on your test, and you know you'll ace this one.